So I hope you can see the slide. Okay. I think you can see the slide. Yes or no? Somebody please tell me verbally, not in the chat box, because I cannot see that.
Yes, sir.
Yeah, you can see the slide. Earth pressure, right? Earth pressure
Yes,
retaining
sir.
wall. Yeah, right. Okay, okay. Chalo. So, so I have discussed in the last class about earth pressure, water retaining walls. Why is it called as earth pressure? So because of this, soil is also called as earth. Then this is filled backside of the wall, so backfill is also called as. Then there are three pressures: active, passive, under earth pressure. So when the wall is moving away from the soil, uh, then soil is going to fail at one point when it is moving away. So just at the verge of failure, the pressure which is exerted by this soil onto the wall is active earth pressure. When the wall is not moving, then the pressure exerted by the backfill is called at rest earth pressure. When the wall is moving towards when the wall is moving towards soil, because of this condition, then also soil will fail. This side soil, you can let me just so the soil which is right side of the retaining wall will fail because it is moving towards the soil. So in that condition, at the verge of failure, whatever pressure which is exerted by the soil is on the wall is called passive earth pressure. So this is just like recap. I'm just telling. Then, so we understood that active pressure will be less than at rest pressure, which is less than passive earth pressure. Then we also discussed Morse circle. Morse circle is drawn to know the stress states in the soil element, any element. So if you take an element of square shape, let us say this, and there are some pressures, stresses which are acting normally. If you see this first figure, let me so if you see this first figure, this one, okay, in that, so there is a element where some normal stresses are acting, and of course there are some elements I told you, you can be given like this. Okay, there are some normal stresses, these are normal stresses, and these are shear stresses. Okay, so like that any element can be subjected by these kind of stresses. Suppose if there are some infinite number of planes inside this, okay, so because of these stresses, okay, on the element, because of these stresses on the element, inside these planes will also be subjected. Let us consider as this is one plane, this is second plane. So because of these stresses, these planes also will be subjected to some normal stresses as well as some shear stresses. Okay, so in case any plane is not having shear stress, that means if the shear stress is zero on the plane, those planes are called principal planes. No shear stress means principal planes because they have only normal stresses. So the stresses, normal stresses on the principal planes are called principal stresses. So the bigger one will be, the larger one will be called as major principal stress, and the plane is called major principal plane. And suppose if the sigma 3 is less than sigma 1, the this is called minor principal stress, and the plane on which it is acting as minor principal plane. So now coming to the Mohr circle, I have told you every point on the Mohr circle is nothing but a combination of two stresses. Suppose this point is nothing but some sigma value, some tau value. this point is also some sigma value, some tau value. So if you take this point and this point, okay, point 1, let us say point 2. See, in this point, sigma value is there, but 0 tau. In this also, there is some sigma values, but tau is 0, right? So let us say this is sigma 3, let us say this is sigma 1. So the planes on which this these stresses are there, those planes are principal stress planes because there is no shear stress, and this sigma 1 and sigma 3 are called as principal stresses. Sigma 3 is lesser than sigma 1, so this is minor principal stress, this is major principal stress. So now this Mohr circle is nothing but collection of points, collection of different combinations of sigma and tau. It's nothing but a element. It's actually representing a element which is subjected to, there are infinite number of planes, including this plane, horizontal plane, then some other plane, like this, like this, like this. Finally, there is vertical plane. So each plane is subjected to different combinations of sigma and tau. If you take all those combinations, if you put in this plane, sigma and tau plane, okay, then you will get this circle. This is called Mohr circle. Now, by using this Mohr circle, you can find out failure planes and the stress, shear stress and normal stress on the failure plane, like that. Now, I told you about failure envelopes also. Failure envelope is nothing but uh, like this. This line is failure envelope. Okay, and I told you about how shear strength is found. Shear strength is combination of normal stress as well as cohesion. Cohesion plus normal stress multiplied by the coefficient of friction. So S equal to C plus sigma tan phi. So S equal to C plus sigma tan phi is nothing but it is analogous to Y equal to mx plus C. So then you can draw this line where C is C only cohesion, M is nothing but here tan phi. So if it is tan phi, then phi is nothing but the angle of inclination of this line. So this line is basically shear strength line. That means this is the strength which it has, any soil has. If it suppose if it has this much cohesion, if it is subjected to this much normal stress, if you can see bottom of the slide, if this is having this much cohesion, if this is having this much normal stress on it, if it is having this much frictional component, frictional angle, then it will have this much shear stress or shear strength. So basically it's saying, this line is saying about shear strength of the soil. So when it is why it is called as failure envelope, because beyond this it will be failure condition. You cannot cross this line, right? So when you are crossing this line, the condition of the soil, that means it is already crossing this point, that means it has already failed, you cannot cross. When it is touching, it is failing. So now what do I want to tell you, um, some insights into this again, some more circle. See, this is very much important. More circle is always very important. So we know there is a failure envelope, let us say. Okay, now you know um, some stress condition. Let us say this is the stress condition in any soil sample. Okay, that means it is subjected to, all the planes in that soil sample are subjected to these kind of stresses. So all are well within this envelope. So this is tau, this is sigma. Okay, let us say this is sigma 3, let us say this is sigma 1, this is major principal stress. Sorry, major principal stress, and this is minor principal stress. Okay, now because there are no tau values are 0. Now if you take any combination on this, that combination is not falling on this line. This line is failure envelope line. This is C cohesion, this is friction angle phi. So if the tau, then this line is nothing but tau equal to C plus sigma tan phi. So where tau is nothing but shear strength in this line. Now, so what do I do? I'll increase one of these stresses. Where I will increase sigma 1, or I will increase sigma 3, or I will decrease sigma 3. Anything, you can change anything. So let us say there is a soil sample. So there is sigma 1, there is sigma 1, and there is sigma 3, let us say. Okay, like this. Okay, there are no shear stresses on this plane because these are major principal, minor principal stresses. So this is sigma 3, this is sigma 1. Now I am increasing sigma 1. I am increasing sigma 1 on this. Okay, now current, let us say sigma 1c, sigma 1c, sigma 3c, sigma 3c. These are current stresses. So this is also sigma 1c, sigma 3c. For current stresses, the soil is not failing because the soil strength is designed by this line, because it has this much c, it has this much friction angle. Okay, sigma is in your hands. If you are increasing sigma, then we will it would be having a different shear strength. Okay, but now coming to this line, coming to this condition of the soil, what will I do? I will increase sigma 1. So but I am keeping sigma 3 as constant. So when you are increasing sigma 1, suppose you have increased up to here. This is now uh, n1, sigma n1, n1, new sigma 1 this is. But sigma 3 is there. So what is the new circle formed? New circle is formed like this. So this is the new state of stresses inside the soil sample when you apply on sigma 1 n1. Right now it is sigma 3, right? Sigma 3c, sigma 3c, but now sigma 1 is increased to sigma 1 n1 from sigma 1c. Because of that, so see the planes, all the planes are having different stresses now. Those different stresses are this is half circle. Now again I increased sigma 1 only. Then what happens? It goes this side. Then finally it touches. Okay. So here when you are increasing slowly at one point of sigma 1 value, it fails along some plane. Suppose this is the plane of failure plane. So this soil is moving down, this soil is moving up, let us say, or in reverse, vice versa. But this is the failure plane. Because of that increment in the sigma 1 continuously, this soil failed along this plane, let us say. Now when you draw the Mohr circle, when you take all the points on every plane, then you will get this circle, okay, at failure. So that circle is touching failure plane at one point of Mohr circle, right? When it is touching on this Mohr circle, so that point is nothing but some sigma, some tau, right? Some sigma, some tau. So those are nothing but common to this Mohr circle, common to this envelope. So remaining points you can see all are well within this, well below the failure envelope, all points. So all planes are safe. The only plane on which this point is having, that plane is shearing because of the, because of that point is equal to the failure envelope point, some one of the failure envelope points. So that is the reason why this point is nothing but sigma failure, tau failure. So now if you can draw this Mohr circle, then if you know the failure envelope, then you can find out this point in the graph. When you find out that graph, then you can find out what is the sigma f, what is the tau f. So you can tell these are the values on failure envelope, sorry, on failure plane. These are the stresses. So on this plane, this is the sigma f, this is the tau f, you can say. That's how Mohr circle is used. Now what do I do? um, I'll just Okay. Now let us say this is tau, this is sigma. Now I have the failure envelope like this. Okay. Okay. Now this is the failure envelope. Now soil, what is this? This is cohesion C and this is friction angle phi. Now the any soil element you take, let us say that soil element has failed because of the application of sigma 1 and sigma 3 on major principal minor principal planes, and other planes are as it is. So now what will I do? So this is the Mohr circle which is representing the soil sample which is just failed. So now I am taking, as I told you, I will consider this as minor principal stress. I will consider this as major principal stress, which is sigma 1, because there is no tau. And this point, as I told you, this is sigma f, tau f, because that point is the point which is representing the failure plane stresses. Now, let us say this is the center of the Mohr circle. Center of the Mohr circle, I'll denote it by uh, small c. Actually, okay. Otherwise I'll make it as S. Okay, this point is center. Okay, and this is origin O. Now this is origin O, then this is sigma 3 value and this is sigma 1, right? This is sigma 1, this is sigma 3 x-axis. So what about this point then? Can somebody tell, can somebody tell me what is this? This is sigma 3, this is sigma 1. So this is the center of this circle. Can you tell me what is this in terms of this is OS equal to how much?
Sigma 1 plus sigma 3 by 2.
Okay, sigma 1 plus sigma 3 by 2. Now, can somebody tell me what is the radius in terms of sigma 1 and sigma 3? Radius means this S sigma 3 or S sigma 1?
Sigma 1 minus sigma 3 by 2.
Sigma 1 minus sigma 3 by 2. So, can suppose this is a failure point F. So, this is at the same time, can you tell me what is SF? What is the value of SF?
Root of sigma 1 minus sigma 3 by 2 square plus tau square.
Why?
Sir, sigma 1 minus sigma 3 by 2.
Yes. Yeah. Because see, from here to here, this is also radius. And what about this? This is also radius. Everything is radius, right? If you join center to any point on the circle, all are radius. Okay. I did not, even if you draw vertically, that is also radius. So it is everywhere it is sigma 1 minus sigma 3 by 2 only. So I'm just giving these points because SF and SO, all these things, because suppose if you extend this line, if you extend this line, okay, this is also phi. Now using let us say this is A and this is B, so AOB, then ASF, using all these triangles you can derive one equation. That equation is, by using all the trigonometric laws and all, sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha, where alpha is 45 plus phi by 2. Okay, so this is what the equation. See here, sigma 1 sigma 3 c is cohesion, alpha is nothing but 45 plus phi by 2. See all values, sigma 1 sigma 3 phi, this c cohesion. So by using trigonometric laws you can derive this equation. This is the main equation which you have to remember. Okay, sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha, where sigma 1 is major, okay, principal stress, and this is minor principal stress. Suppose somebody wants to take this as sigma 3, just numbering is different. This has sigma 1, they just wanted to take this, that's it. Then equation will be sigma 3 sigma equal to sigma 1 tan square alpha, like that. You can, wherever sigma 3 you can write sigma. Why I am saying this, see, it is this here left hand side major principal stress will be there always, right hand side this first term will be minor principal stresses. So you can see from this diagram. Now, so if you remember this, now I'll go to the point where active, passive, and sorry, okay, this is one. So this is another condition of retaining wall. Okay. So what I'm saying is that, let us say this is at rest. Okay. And this is active. This is passive. Now, in if you take any element, see in the previous classes I told you how to calculate sigma v dash at any point. This is nothing but gamma multiplied by gamma effective. It may be gamma submerged, it may be gamma bulk, or it may be gamma dry. Okay, gamma is nothing but unit weight multiplied by the height at which you are, suppose this is height, this is point, then gamma multiplied by height equal to effective stress at that point. Okay, this is what I told you. This is nothing but what, at that point what is the vertical stress. Okay, now you know the vertical stress, but you should know horizontal stress right now. Why? Because what is the horizontal stress or horizontal pressure which is acted by earth on this wall, that is what we want to know. So at every point you can find out sigma v, because gamma into h, and if there is water table you know how to deduct from the gamma sat minus gamma w. So like that, at every point you can find out gamma sigma v dash vertical stress. So vertical stress can be converted to the horizontal stress. Okay, if it can be converted, then you can find out the horizontal stress. So let us say uh, when wall is not moving, there is some certain sigma v and certain sigma h. There are some certain values. Okay, another thing here, so if I take this element, okay, it is nothing but replication of this element just above it, that's it. Now there is no shear stress. If you see, nobody is applying any shear force, but what is happening, if you go down there is some vertical stress. So you can say, by that you can say this horizontal plane is nothing but principal plane, because there is no shear stress. If you take horizontal plane, that is, in this case, in this particular case of thing, horizontal plane and vertical plane, these both are principal planes, because principal planes are always perpendicular to each other. So you know one horizontal is principal plane, automatically vertical plane is also principal plane. So now you understood that sigma v comma sigma h are principal planes. Okay, principal plane. Sorry, principal stresses. Okay, now which that is what we understood now from the diagram. But which is more, whether sigma v is more or sigma h is more? We don't know, right? Anything can happen. So any case, no issues. Anything can happen out of these two. Now we will move to next case. Now at rest position, this is the condition. If this is the condition, can you draw the more circle for this? Okay, what will I do? So at rest condition, soil will not fail, as we know, because soil is not moving at any direction. So so now this is tau, this is sigma. Now I know some sigma v is acting, some sigma h is acting horizontal. Okay, now both are principal stresses. Okay, but I don't know which is more, which is less. Let us consider sigma, this first condition. No issue, any condition is fine. So sigma v is greater than sigma h. So I'll consider sigma v is greater than sigma h. So if that is the case, if you want to draw the more circle for that element in the at rest condition, you know, right? Now you know major principal, minor principal stresses, which are nothing but sigma v and sigma h. Major principal stresses, minor principal stress will be on the x-axis because there is no tau. So then you can draw sigma v here because that is greater than 1, and sigma h here. Okay, now if you know this, what will I do? I can complete the more circle, because when you know this, what can you do? You can find out the center of these 2 points. After finding the center, then you know the radius, then you can complete the circle. So now I completed the more circle. Now for that soil, we have one failure envelope, right? That failure envelope looks, suppose, like this. Okay, failure envelope looks like this. So now at rest condition, soil is not failing, that's why it is well below the failure envelope. Okay, this is S equal to C plus sigma tan phi. What will I do? Now I'll go to active. Active will, how will it form? Active, now wall should move in this direction. When the wall is moving in this direction, then slowly this soil will also tries to move in this direction. It will try to move in this direction. When it will try to move in this direction, so soil will fail along this plane. That means this total wedge, this wedge will move in this direction. Okay, whereas this soil will be intact, because of this retaining wall movement, the soil beyond this plane will not have any effect. So now this is the plane. I told you this is the angle 45 plus phi by 2. Now can somebody tell me, suppose I considered this element initially, let us say this is the element initially at this point. Now one of you can tell me, anybody, because of the movement of this, because of the movement of the wall away from the soil, sigma v and sigma h are there. So what, first sigma v will change, sigma h will change, or both will change, or none of them change, none of them changes. Okay, can somebody of you tell me what is the answer? Now wall is moving in this direction. So what is the can you just choose one of the options, or two of the options, anything is fine. Can you make it fast?
Roughly 10 minutes.
10 minutes back. Okay, then I
Yes,
am
sir.
teaching to the air maybe. So let me share this. Oh, it's not there. So, I hope you can see the slide. So can you tell me where were we when it is stopped? The meeting was stopped.
Sir, right, right after you said that SF bar is the radius. You give the explanation there.
Acha, okay. So you have missed so much then. Okay. So now after that, what did I tell this? This is the equation. Did I say about this equation? This e
Yes, sir.
this equation was also there in that video. I mean, last in the last part of the class.
Yes, sir.
Okay. Anyway, so I'll repeat it. So once in a while I should check then. Okay, fine. So now what I'm telling that. So here there is sigma 3, sigma 1, and there is phi, and there is cohesion in this diagram. So in this diagram, by using the triangle properties, you can derive this equation, where this equation is sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha, where alpha is 45 plus phi by 2, and sigma 1 is the major principal stress, sigma 3 is the minor principal stress. That means you have to take LHS of that equation always this point. You may use sigma 3, you may use sigma 1, it doesn't matter. So that this stress should be left side of the equation. Okay. Now after that, what did I tell? I have drawn these three diagrams where three retaining walls. Okay. So first retaining wall is telling about the at rest condition. Second one is telling about the active condition. Okay. And third one is telling about the passive condition. Fine. Now, in the at-rest condition, I told you, I was telling that you can take one element where that element is subjected to some vertical stress and some horizontal stress. Fine. Now, as this, if you see this top of the layer, top of the earth, there is no shear stress here. There is no shear stress in this direction. Okay. And if you go below this element, normal stress is slowly increasing. Okay, from 0 to some value. How it is increasing? It is increasing in this manner, gamma into h. So normal stress is only there at any element, but there is no shear stress on the horizontal plane. So then that plane is called as principal plane. So always there will be two principal planes which are perpendicular to each other, correct? So there should be another plane that is also principal plane, that is vertical plane, because this is horizontal and that should be vertical. So what is that? So on the horizontal plane, sigma v is coming. On the vertical plane, sigma h is coming. So then sigma v and h are principal stresses. Now, which is more? We don't know whether sigma v is more than sigma h or sigma h is more than sigma v. But we don't know. You can write two conditions are possible. Let us say sigma v is greater than sigma h and sigma v is less than sigma h. But both are principal stresses. Okay. Now, but soil is not failing because it is at rest condition. Soil should move in some direction to move to fail. So for this at rest condition, what did I do? I have drawn a Mohr circle. How did I draw? You see, you can see this. See this, there is a tau, there is sigma, okay, x-axis and y-axis. Then this is the failure envelope for that soil. Now what did I do? I took this condition. So anything is possible out of these two. Sigma v is greater than sigma h or sigma v is less than sigma h. You can consider any case. So I am taking first case. Sigma v is greater than sigma h. Sigma v is greater than sigma h. And I am drawing them on the x-axis because their respective shear stresses. Suppose there is an element now here, sigma v, their respective shear stresses are 0. Okay, there is, these are 0 here as we talked. Because of that, sigma h comma 0, sigma v comma 0, and sigma v is greater than sigma h, you can see here, right? This is the at rest condition. This is at rest condition. Okay, now soil is not failing. Because of that, see, this is the failure envelope, right? Failure envelope. So that's why it is not touching, because it is not failing. Now I'll go to um, active condition. In the active condition, okay, in the active condition, I will take the same element. Okay, I will take the same element. Now initially there was sigma v and sigma h, of course. Okay, let us say this is sigma v1, sigma h1, and initially sigma v1, sigma h1. Now what I'm doing, I am moving this wall away from the soil. Okay, when it is moving away from the soil, as I told you in the previous class, there is some soil wedge like this. This is the soil wedge. Okay, this triangular. That will also move in this direction, in the downward direction, you can say simply. Suppose, isn't it? Suppose there is like this. So you are moving in this direction. Fine. So this there is, if it is moving in this direction, what happens? Slowly it tries to come down. Okay, like this. So anyway, now um, sigma v, sigma h, and we know how to calculate sigma v, right? Okay, see, you don't think that there is much height difference. Okay, there may be difference between this layer and this layer, the next position, but the point was here and now point is here. Okay, actually it is very minor. You can't see with eyes like how much the rotation of the retaining wall when it is failing. It is like 1 degree, 2 degree, it will fail. That is active earth pressure. Okay, now my question is in this, when the wall is moving away from the soil, okay, when the wall is moving away from the soil, then soil fail at some point and this total wedge fails. That means this is the failure plane. Okay, this is the angle of failure plane as I told you in the previous class. Now I want to ask you, when this is the condition, when the wall is moving away from the wall and it is failing at one point, at that point or during the process, during the movement of the wall, what is the option which you consider here, which is correct option? Whether sigma v changes or sigma h changes, or both will change or none of them will change. That is the those are the options. Can you tell me? Can you tell me soon? Even if it is wrong, no issues. You can tell me. Imagine.
Sigma has just changed.
Sigma h will change, right? So will it decrease or increase? Can you tell me, will it decrease or increase?
Increase.
It will increase. How? Anyway, no issues, no worries. See, when the wall is moving away, sigma v will not change because there is no height change of any point. It will be gamma into h. Sigma v will not change. Okay, even if it is moving in this direction, then also there is a failure. Okay, this is 45 minus v by 2, this failure angle. Then also sigma v will not change. Okay, in this condition what happens, sigma h changes because you are releasing the pressure in the horizontal direction, because this is moving in the horizontal pressure, you are releasing the pressure, so sigma h will decrease. Here you are moving towards the soil, that means you are again pressurizing the soil. Because of that, sigma h will increase in this condition. Sigma h will increase in this condition, sigma h will decrease in this condition, in active condition. So these are not valid anyway. So now at one point they will fail. In this condition also at one point they
Sir,
will fail. Tell me.
sir, why passive, sir, increase?
Because see, it's nothing but, see, soil is there behind it. Okay. Now there is a retaining wall. Now you are moving the retaining wall towards soil only. When you are moving towards soil, see, this soil is not ending here. This soil is infinite length. Okay, now you are pressurizing the soil. Okay, in this direction you are pressurizing. When you are pressurizing, of course, so there will be more pressure on this element, and because of that, the wall will get more pressure from the soil, right or not? You're getting the point?
Yes, sir.
You're just pressurizing soil. It's common sense. Okay. Because of that, sigma h will increase. Here, sigma h will decrease because you are loosening the soil. When you are loosening the soil, of course, the existing sigma h will decrease. Okay. So now you understood what will happen in active, what will happen in passive. Sigma V will not change, but sigma H will change. Sigma H will decrease in the active earth pressure. Sigma H will increase in the passive condition. Okay. Now coming to this diagram where at rest pressure, at rest conditions, more circle is ready and their soil is not failed at this condition. That's why it is well below. But in active and passive, soil fails at one point, right? At that point, we will draw the more circle now. Okay. Now how active condition is happening? Active condition is happening because of the change in the sigma h. That change in sigma h is nothing but decreasing the sigma h. Okay, sigma v is constant. So in active, sigma h will decrease. In passive, sigma h will increase. Now what will I do? This is the original condition, at rest condition. Now I am decreasing the sigma h value because wall is moving away. So it is slowly going in this direction. Sigma h is going in this direction because it is origin. So at one point it is going, at one point the soil fails. So after that you cannot move and you cannot get more circle because when it is what, so let us consider at this point initially. So this is the more circle. Why it is the more circle? Sigma v is constant, I am telling. Sigma h is moved this place. Now sigma h is moved to this place. Okay. So now this is the new more circle. When sigma h has reached this point, it is decreased, it reached this point, sorry. Okay. Okay. When sigma h is decreased to this point, then at that point, at that point, the more circle is touching the failure envelope. So it is failing. Now sigma h is here. Okay. Sigma h is here. After failure in the active condition, which is more, sigma v is more or sigma h is more? In active condition, I am asking. In active condition, at failure,
Sigma V.
sigma v is greater, sigma h is lesser, right? You may tell me, sir, you started from directly sigma h is less than sigma v. That's why you ended up with sigma h again less than sigma v. Okay, you might ask this question, but so I'll go for another thing. Okay, this is the failure envelope. Okay, in the initial condition, what will I do? What did I take in the initial condition? I just assumed that sigma h is less than sigma v. That's why this. So then after that, you have to decrease sigma h to get the active condition. That's why I moved in this direction. But in case sigma h is greater than sigma v in the active condition, okay, in the active, sorry, in the, sorry, in the at rest condition. Now we will draw the Mohr circle for the active only, for the active condition only. Okay. In the active condition, what will happen? Sigma h will decrease, sigma v will be constant. That we know anyway. Okay. So I'll keep this point as constant. Now I should decrease this sigma h. Okay. Now I'll start decreasing slowly. Let us see when will it fail. So I have decreased up to here. Okay. Sigma h1. So what will be the more circle? More circle will be like this because diameter has decreased, right? Is it touching the more envelope? No. Now I'll go for again sigma h is here. Sigma h should only decrease. There is no option. I should move only left direction. Again now, more circle is this. At one point sigma v and sigma h are same. Then slowly you are still moving the wall away from the soil. So again sigma h is further decreased. Now another more circle formed. Sigma h is decreased. Another more circle formed. V is constant always. Like that, at one point, at one point, it will touch this line. Okay, this is the initial. Then you are decreasing sigma, keeping sigma v constant. Then slowly, finally, you have reached this sigma in the active condition when it is failing. Now tell me at failure in active condition, which what is the symbol should I write here? Again, sigma v is greater than sigma h. So what you have to remember is here also sigma h is sigma v is greater than sigma h, right? So who is that? Amit, please mute yourself. Okay. So now what I'm trying to say is that in the active condition, always sigma v will be greater than sigma h. Okay. So you understood. Whichever the condition, initial condition, finally sigma h will be left side of sigma v, then only it can fail. So in the active condition is that. So in reverse, in the passive condition, what should suppose this is the initial condition. This is the initial. Sigma h is here, sigma v is here. Sigma h only should change in the passive also, but in this case, sigma h should increase. So when the sigma h is increasing, suppose I have increased up to here, then new circle will be formed here. So I have increased up to here, from here to here, sigma h. Then you, so like that at one point it will be same. Then sigma h is here, here. So continuously you are increasing, at one point it touches. So sigma h will be somewhere that side. So in the passive condition, sigma h will be greater than sigma v in the passive condition. So though you start this condition, initially what is this? This is the initial condition, right? Sigma h is right side, sigma v is left side. Okay. So this is another condition, at rest condition. Now you have to increase the sigma h for passive condition to occur. So now new sigma h is here. So like this, another sigma h is here. Like that you will. Finally sigma h will be right side only. So sigma h is greater than sigma in passive condition. And sigma h will be less than sigma v in the active condition. Okay, so these we understood. Now if you understand these things, at failure in the passive condition sigma h is greater than sigma v, at active condition at failure sigma h less than sigma v. Okay, what are those? You understood that they are nothing but, if this is a failure envelope, they are nothing but, if this may be sigma v, this may be sigma h, whatever, irrespective of any condition, these are principal stresses, right? They are principal stresses. Now I told you this formula. I told you this formula. Sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. This formula or this equation is derived from nothing but any Mohr circle whose ends are sigma 3 and sigma 1, and which is touching the failure envelope, whose cohesion is C, right? Now in this active passive condition also, there also instead of sigma 1 sigma 3, just sigma h sigma v have come, that's it. Okay, rest all things are same. This is C, this is phi. Okay, now if I write again, sorry, if I write again sigma 1 sigma 3 tan square alpha plus 2c tan alpha, where alpha equal to 45 plus phi by 2. Now I will ask you to write in the active condition. In the active condition, if I want to replace sigma 1 and sigma 3 with sigma h and sigma v, can you tell me in active condition what can I write? I told you sigma 1 is major, sigma 3 is minor. So minor should be on the RHS side, major should be on the LHS side. Okay, now in active condition at failure, if you replace sigma 1 and sigma 3 with sigma h and sigma v, so how will you replace? Where will you keep sigma h and where will you keep sigma v? Anybody? You can just try.
Sir, sigma V on the left side and sigma H on the right side.
You are telling this, right? Okay. And if it is passive condition, if it is passive condition,
Sigma H.
si-
Sigma H equal to sigma
sigma
V
v tan square alpha
tan
plus
square.
2c tan alpha. Okay. Equation is same. Even sigma v and sigma h are also principal stresses. Just that in the active condition, sigma v is major principal stress. In the passive condition, sigma h is major principal stress. That's it. Now, what can we do is that first I'll write this equation. I'll derive this. Okay, fine. Okay, in the active condition, we know sigma v equal to sigma h tan square alpha plus 2c tan alpha. Okay, where alpha is 45 plus e by 2. Now, what will I do? I know how to find out. Let us make it effective stresses. Okay, they are effective stresses. They cannot be total stresses anytime. Okay, now what is our aim in this? What are we studying completely? We are studying about earth pressure. We want to know what is the pressure which is coming onto the wall. That is what our aim. Aim of the study is finding the horizontal earth pressure. Okay, this is the aim of the study. If you know the horizontal earth pressure, then what will you do? You will design the wall according to the pressure. Okay, you will give the thickness, you will give reinforcement, that iron rods inside it, steel rods. So you will design the wall according to this much horizontal earth pressure. So this is the aim. Now, after after deriving everything, okay, what is our aim in this? You can find out sigma v, because sigma v dash is nothing but gamma dash multiplied by h, or gamma bulk multiplied by h. If there is water, gamma sat minus gamma w multiplied by h. You can find out sigma v. So you have to find out sigma h. That is what our aim of the study. So you know the C value, cohesion value, you know the frictional angle value, you can use and you can put it into here. Then finally you can find out what is sigma h from this equation. So but better we will make, we will bring it to left side, then everything should be right side, only left side sigma h should be there. Like that we will make the formula. Okay, let us make the formula. So now sigma h dash tan square alpha equal to sigma v dash minus 2c tan alpha, and sigma h dash equal to sigma v dash by tan square alpha minus 2c by tan alpha, because it is tan square, so tan will be cancelled. Now this is the thing. You can find out sigma h here. See here, uh, I'm telling you, this equation, you can go through any standard book. or else you can use your trigonometric laws and all. You can derive this equation from this diagram. You can derive this equation. Okay. Second thing is, now this tan square alpha is nothing but what? Tan square 45 plus phi by 2, right? This can be, tan square alpha is nothing but this can be written as tan square, suppose 1 by tan square, this is 1 by, right, 1 by tan square alpha means 1 by tan, it can be written as tan square 45 minus phi by 2. Tan square 45 minus phi by 2 can be written as directly sigma v dash is d sigma v dash. So 1 by tan square alpha is nothing but 1, it is tan square 45 minus phi by 2. That can be written as 1 minus sin phi by minus 1 plus sin phi. So this you can derive. There are otherwise you can go through any YouTube videos, these are completely available. Okay, even in the Google they are available. So now 2c, in place of tan alpha, what can you write? You can just write under root of 1 minus sin alpha by 1 plus sin phi. Okay, this is the equation for the active earth pressure. For the active earth pressure, I have derived by putting sigma v left side, then I brought sigma h to the left side, then I found out this. What will I do right now? I will give this, I will take this as Ka, K suffix A. Okay, if I keep it that as Ka, sigma h dash is equal to sigma v dash into Ka minus 2c under root Ka. So this is the equation where Ka is, you can find out by using friction angle. Okay, now Ka is called as coefficient of active earth pressure. Active earth pressure. Ka is called as active earth pressure. If you know Ka, first of all you can find out Ka. If you know Ka, you can find out, suppose how it is changing sigma v. If the gamma is 10, if gamma is 10, so it will change like this, no? 10 into h, if this is h, right? Suppose this is h by 4, 10 into h by 4, gamma is h. So it varies like this linearly. This is sigma v dash. What about sigma h? You just have to multiply Ka. That's it. You just have to multiply Ka to the sigma v at any depth. So you will get this part. Then you have to deduct this part 2 multiplied by cohesion multiplied by under root of coefficient of active earth pressure will give you the total horizontal earth pressure, active earth pressure. This is only for active. Okay. Now, if it is cohesionless soil, that means the soils which do not have cohesion, they are generally sand. Sandy soils generally do not have cohesion. C is 0. In that case, in the sand case, sigma H is directly Ka into sigma V dash. In sand soils, sands or cohesionless soils, C is 0, then it will be converted to like this. Now, if you, so I think what is the time now? I think we can stop the class. In the next class, I'll discuss about equation for calculating passive earth pressure. Sigma h equal to what is the equation? That will take only 10 minutes. Then we will solve 3 problems. You will be having clear idea in the next class how to calculate earth pressures. Okay. So I'm closing this session with this. So is there any doubt in this class?
Sir, if some videos are some classes are missing, then how we see this
Acha. Yeah,
live
actually,
session?
I am uploading live sessions into the Gate NPTL for them. Okay, for those who are actually organizing this. I don't know from where you have got to know this. Okay, about these live sessions are happening. You are attending, so somehow you are informed. So you can mail them. They will share you the live video. I mean live sessions. Okay, I'm uploading to them. I'm giving it to them, organizers. Okay, so you can ask them or you can mail them from where you have got to know this link and all. Okay,
Sir, mail ID?
mail ID
Which
that.
mail ID I will send, sir?
But how do you people know this? This something is happening like this. So how did you attend this class? Who told you? Like how are you informed?
Uh, YouTube I saw.
Ah,
YouTube.
in YouTube.
YouTube.
Cha.
Um,
But this is properly informed through some links. I think so. Okay, I'll let you know in the next class. Okay. By the time I'll
okay,
be
sir.
talking to them and I'll ask. Okay. They will share you the videos.
Okay.
Okay. Okay.
Thank you, sir.
So, okay, I'm closing the session then.
Actually, that is available from Gate portal.
Acha, Gate portal, direct live sessions
Yeah, yeah,
also.
yeah, yeah. Miss Gate NPTL portal.
Okay, okay, okay. Nice. Okay.
Okay.